Good morning, algebra students. So today we are looking at the notes for 1-2, algebraic expression vocabulary. Most of this is vocabulary we did at least touch upon, if not fully go over in 7th grade, so it might be familiar to you. If not, well, that's why we're going over it. So first one we're looking at here, term. A term is separated by addition or subtraction. They are composed of multiplication and division. So you'll see in the example over here, this would be like starting with the full out expression 2x cubed minus 5x squared plus x plus 9. So that full expression has 1, 2, 3, 4 terms. And you can see that they broke it down. 2x cubed is one term, negative 5x squared is another term, the positive x is a third term, and that positive 9 is a fourth term. So 4 terms total there. I'm just going to make a little note of that it says, that it's 4 total terms. Okay, terms keep separated by separated by addition or subtraction. You can see here I have a second example that I typed in, this giant thing that I just highlighted. Now notice here, you'll notice this is all one term. This is one term only because there's no addition or subtraction going on. You might think, well, if there's no addition or subtraction, then there should be 0 terms. Well, that doesn't make sense because if it was 0 terms, there would be nothing there, and there clearly is something there. So it's just one big term when there's all multiplication or all division going on there. No adding or subtracting there. Okay, the next term on our list is reciprocal. Reciprocal. And the fancy name for reciprocal is that multiplicative inverse, which is that flipping of the fraction. Now, over here in our example, you'll see we have 4/3. The reciprocal of 4/3 is 3/4. The reciprocal of 8 is 1/8 because 8 over 1 flipped is 1 over 8. Now you'll notice here that when you multiply a number in its reciprocal, you end up with 1. So a number times its reciprocal will always equal 1. 4/3 times 3/4 is 12 over 12, which is always 1. An algebraic expression. An algebraic expression, well, it's algebraic, so it must have at least one variable. It needs to have at least one variable in order for it to be considered algebraic. It can contain, or it can have, numbers, obviously, operations, add, subtract, multiply, divide, exponents. What it can't have, though, because it's an expression, is no equal sign. And you'll see that in the example that I gave up there. It's got operations, variables, but no equal sign. So these guys, monomial, binomial, trinomial, polynomial, that just has to do with the number of terms in the algebraic expression. All of these are just algebraic expressions. So these are all just algebraic expressions. From our examples, you can see that a monomial just has one term. A binomial has 2 terms. Binomial, bicycle, 2 wheels. Trinomial, tricycle, 3 terms. And polynomial, you might be connecting that back to like polygon shapes and geometry. Polynomial is just multiple or many terms. So again, all of those monomials, trinomials, polynomials, all of that stuff is just, all of those are just examples of algebraic expressions. So, yeah, okay, moving on. Absolute value, this we definitely talked about in 7th grade, at least a little bit. Absolute value is, let's go purple. Absolute value is a distance. A distance from 0. And because it's a distance, it can never be negative. So, for example, the absolute value of -3 is 3 because -3 is 3 spaces away from 0 on the number line. Similar to that, the absolute value of +3 is still +3 because 3 is also 3 spaces from 0 on the number line. All right, degree of a polynomial here. The degree of a polynomial has to do with the highest exponents. The degree of a polynomial is the highest exponent in the expression. So if you look at our first example here, 4x squared plus 2x minus 3, that has a degree of 2 because 2 is the highest exponent. In our second example, the highest exponent is 3, so this one has a degree of 3. I'm just going to abbreviate that d of 3. A coefficient. Definitely talked about this one in 7th grade also. A coefficient is simply just the number in front of the variable. And again, it can be any kind of number. A decimal, fraction, whole number. So we've got some examples here. 6 is the number in front of that A. 1 is the number in front of the B. 2 is the number in front of the x squared and the y. So those coefficients. That leads us to a leading coefficient. A leading coefficient kind of combines degree and coefficient. A leading coefficient is, it's still a coefficient, so it's still the number in front of the variable with the highest exponent. So you'll see in this example here, this has a degree of 3 because that's the highest exponent, degree of 3, which makes the leading coefficient the number in front of that variable, which is the 4 that they're pointing out. 4, 2, and 7, -7 actually, are all coefficients also, but 4 is the leading coefficient because that's the one in front of the highest exponent. A constant is simply just a number without a variable. And again, it can be any kind of number. 7 squared is still considered a constant because 7 squared is just the number 49. 1 1/2, -4, 5/3, fractions, decimals, it can be any kind of a number. Exponents, which probably should have went before we talked about degree, but anyways, exponents are those smaller raised numbers. And keep in mind that they represent, and this is the important part, they represent, I'll start this, repeated multiplication. So when you have 2 being raised to the exponent of 5, like we have in our example over here, that means that you're repeatedly multiplying the base by itself the number of times the exponent tells you. So 2 by 5. 1, 2, 3, 4, 5. 2 times itself 5 times. 1, 2, 3, 4, 5. Repeated multiplication. Like terms here, remember that like terms must have the same variables, and that can be either one variable or multiple variables, must have the same variables, keyword and, both of these things need to be true, and the same exponents. So you can see we have examples of 2x and negative 5x. They both have an x. A and 1/2 a both have a's. X and y squared, x and y squared. Notice both of the x's have an exponent of 1. Both of the y's have an exponent of 2. That's important. If that exponent was on the x instead, that would change things. Notice our unlike terms examples, y and y squared. Even though they have the same variable, they don't have the same exponent, and that just doesn't count. And last but not least here, as we wrap this up, is standard form. Standard form just means that the polynomial or the expression, the polynomial is simplified entirely, which means, no like terms. And then this is the new piece. And your exponents are ordered from greatest to least. So in our examples, you can see yes is the example of 1 in standard form because the exponents go 8, 2, 1, and then none. This guy's not because the exponents are not ordered from greatest to least. 2 is first and then the 8, and that's not from greatest to least. This third example here is not in standard form because there are like terms that can be simplified still, that those x squared pieces can be combined. So there is your notes for 1-2. Make sure you give the homework problems a try.